Example 3. We are given that GJ bisects angle OGH. So this is GJ, and we know that it bisects OGH. Now, again, if something bisects, remember that means it essentially cuts in half. So by that statement, I now know that this angle is congruent to this angle. We have to prove that triangle GJO is congruent to triangle GJH, so that this guy is congruent to this guy. Now, if I'm trying to prove triangles are congruent, remember we have some options. We have side, side, side. We have angle, angle, side. We have side, angle, side. And we have angle, side, angle. And I already know because of that bisect that this angle is congruent to this angle. So the next thing I'm thinking is maybe I could prove that this side is congruent to this side and that this side is congruent to itself. So we're going to do this by side, angle, side. So the first thing I need is one of the sides, and I'm going to start with the easiest side. So I'm going to prove that GJ is congruent to itself. So GJ is actually equal to 1, 2, 3, because we went from 2 up to 5. So that equals 3, which on that one you can just count it, which is equal to GJ. So I know that one of my sides are congruent. Then I'm also going to state that angle OGJ is congruent, so that's OGJ. So this angle is congruent to HGJ, this angle. By the definition of bisect, in my given, they told me that this thing was bisected. Bisected means cut in half, so I know those have to be equal. So then the last thing we have to prove is we have to show that OG is congruent to GH. Now in order to do that, this is where that Pythagorean theorem is going to come back into play. So I'm first going to find OG. And in order to find OG, I'm going to make my right triangle, and I'm going to count the distances. So the bottom is 1, 2, 3. The top, or the vertical, is 1, 2, 3, 4, 5. So this is going to give me 3 squared plus 5 squared equals OG squared. A squared plus B squared equals C squared. So this is 9 plus 25 equals OG squared. This is 34 equals OG squared. So then if we take the square root, I'm just going to leave it as the square root of 34 equals OG. Now we have to find GH. So in order to do that, I'm going to drop this down. I'm going to drop this over. I'm going to count 1, 2, 3. That's 3. This is 5. So GH. We're going to have 3 squared plus 5 squared equals GH squared. This again should look very familiar. So we're going to have 9 plus 25 equals GH squared. That again is 34. And then we're going to take a square root. So we can see that GH is also the square root of 34. So now we have a side, we have an angle, and we have a side. So in step 2, we can prove that triangle GJO is congruent to triangle GJH by side, angle, side.